Alright, so here's a breakdown of how to make the arrows go on the back problem here for the X-ray view. Here's how I found the forces, external forces. Here's statically determinate, and finding the angles, which happen to be the same on here. So now for the arrows to go along with these, if that's the up, this has to be down. If that's down left, this has to be right, which makes that left. And then I go up here. If that's an up, that has to be down. This has to be left, which makes that go that way. And then kind of the same deal over here. If I focus on this one, we have an up and a right. So this has to be a down. The only thing to fight that up would be a down. And then if both of these are pushing right, I need a left here. And that makes that go that way. And that makes this go that way. Okay, so that beam has opposite forces. Now I have two lefts. I have an up, so that means I have to have a down, and I have to have a right. So I'm kind of cruising through here. If that's an up, this has to be a down. If that's a right, I need a left here. So I'm kind of just going through here. If that's a right, this is a left. And then there is no down, so I can write 0 there. Let's see, there's one more side I don't really know. Let's see if we can figure it out here. Yeah, there's one up, so this must be a down. Which makes that one go that way. Alright, so we got them all, which is cool. There's no unknowns, and there's only 1 0. Oh. Yeah, so this doesn't, I was going to say that has to be 0, but it doesn't, because there's a down and an up. Alright, so there's that. Let's pause there. Okay, so now when I'm deciding what to go after, I can go after joint A and joint E. We've done that a few times. Joint A is probably the easiest one, so I'll pause and do that. Alright, so I went after joint A, and I made FAB times sine as the vertical part, found an answer, took it times cosine to find FAF, so now I know those two numbers there. So I can write 848.4 here, and I can put 662.5 here. So I found those. I can do a similar thing on E to find the vertical part. I'm going to pause and do that. Okay, so similarly, I found out if there's only one up force of 70, I can turn FDE into its vertical part and find the diagonal down force of 112.50 pounds. Now, the horizontal one's not as easy as over at A because I actually have two right forces. So one right force comes from here, and one right force comes from this guy times cosine. So FEH will actually equal the 400 plus the right version of this, which is 112.05 cosine 38.66. So it's a little more complicated, but you're pretty much just adding 400 to whatever's going on there because of the pterodactyl, of course. So 400 plus 112.05 cosine of 38.66. And we have 487.50. So we got our other number here, 487.50. And now I can go after B is the next not logical choice because you have a diagonal up, and then you can turn it into its vertical part and its horizontal part. So I'll pause and do that. Okay, so if I drew that out, I turn this into its vertical part by using sine and get FBS as 530. Then I turn it into its horizontal part by using cosine and get 662.50. So now we're filling in some stuff. This is 662.5. And this one is 530. Okay, now we're getting moving here. You can go up to joint D and do a similar thing. So we'll have a lot of these filled in after we get all 4 of these. So let's pause and I'll do that one. Okay, so this one, going after joint D, there's only one up that fights that down. So you just take the 112.05, that was 05, times sine, and you get 70.0, which makes sense because it was 70 up down here. And then this one, you do the 112.05 times cosine plus the 400, because there's 2 left forces. It's 400 and the leftiness of this, so you take that times cosine, and you add them up, and you get 487.5. So we'll put that on our picture. We got a 70 going down here. And then we got a 487.5 here. Alright, now we're getting to the crazy parts here. Now we got to pick one of the bad ones to go after, because we picked all the nice ones. Let's see. I would say that H looks like our next nicest. And the reason is, it's better than F. F has a down and up, a left or right, a diagonal. I don't want that. C looks pretty crazy. Because there's a lot of unknowns here. I could do it, but I don't want to. G, I don't know enough about it. So I like H. So joint H is next. Let me pause while I draw a quick picture. All right, so for this one, FCH, this diagonal here, it's a down force, and it's only being fought by that up force. So it's down and right, so I'm going to go with FCH times sine equals 70. And FCH must equal over 70 divided by sine of 38.66. And we get another 112.05. So that's the other diagonal, 112.05. And then if I want to find the FGH, it's going to equal this horizontal plus that one, because there's one left, that's FGH, and it's those two added up. So 487.5 is straight right. And then I have to turn FCH, which is 112.05, with cosine into its horizontal part. So 487.5 plus 112.05 cosine, 38.66. FGH will equal 575.0. Okay, so we got a 575 is this one. Which means I know this one, because G is easy. And now we have one last one to go to, and it's finding this last one. I would probably just do it the same way I did this one over here. I don't really want to go up to C, so I'd probably go down to F and redraw it for our last one. Alright, so for my final move, FCF is a diagonal up, and I'm going to turn it into up with sine. So 530 plus this guy's up must equal 600. So I'm going to do FCF times sine of 38.6 degrees plus 530 must equal 600. So you'll do your subtraction, you'll get 70, and divide by that, and we'll see a number we've seen before. It'll be 112.05. So my final missing piece is 112.05 pounds. So that's crazy. That's a lot of stuff. If you can do this, you can pretty much do any of them. We had sideways, we had diagonals. There's only 1 0. All these other numbers were kind of different. Wow. All right. Hope that makes sense.